All right, guys, happy Thursday. We're going to do some notes this way today since I'm not here. So you should have your packets out, open to page 6. You should be taking notes as we go. And then I would also encourage you, if there's things that aren't making sense or if you have questions, that you kind of jot those down off to the side so that you can ask me tomorrow. So what we're going to work on today is sketching quadratics in standard form. We've been working a lot with what we called graphing form, which is what we've been working on the past few days. It looked like this. Remember, it allowed us to figure out where our vertex was, if it was opening up or down, and then if we had any sort of stretch. So we could create a really nice graph of a parabola pretty quickly just by looking at those couple of things. We talked about standard form a little bit last unit. The ones that we looked at were pretty easy ones. They're going to be a little bit harder in this unit just because if you notice, now we have a number in front of our x squared. So that's going to make factoring just a little bit harder. So just like we talked about, standard form isn't as nice. It doesn't really give us a ton of information just from looking at it. However, we're going to talk about how we can figure out the orientation, so if it opens up or down, as well as it does actually allow us to see a stretch. It just doesn't really tell us kind of where that parabola is centered on our graph, like where the vertex is or where the x-intercepts are. We have to do a little bit of work to get that. So first thing says, what is the orientation of the graph? That is, does it open upward or downward? How do you change the equation to make the graph open the opposite way? So it's very, very similar to how we did graphing form. We're looking at the number at the very front, and that's really the number before our x squared. So since this number before our x squared is positive, our graph is going to open up. So it opens up because that 2 is positive. And if we wanted it to open down, just like with vertex form, we would need a negative up front. So if we wanted to open down, right, we need to turn 2 into -2, right? That's going to cause it to open down. So that 2 tells us if we're opening up or down. It also is telling us our stretch, right? It's very much like the A that we had when we were in graphing form. It's actually the same. So our stretch factor here is 2 because this is the number before x squared. Okay. So can we identify the vertex by looking at the equation? If not, we're going to talk about some strategies, right? Just like we discussed, standard form doesn't really tell us a ton of stuff, right? It doesn't tell us the vertex. It doesn't tell us our x-intercepts at all. So we need to do a little bit of work to get that. The first thing it's asking us to do is find out what the x-intercepts are. So if we're on the x-axis, remember that our y coordinate, no matter where we are, is always 0. So we're going to set our equation equal to 0. And you'll notice here, right, these numbers are kind of big. It's also a little bit harder to factor because we have that 2 out front in front of x squared. Anytime we have a number in front of x squared other than 1, we can't do that multiply and add kind of trick. It doesn't work. We have some other strategies that we can use, but it takes a little bit more work. However, if you notice, all of these numbers in our equation are even, which means we can actually factor out a common factor of 2 from everything. So if I'm factoring out a 2, that's like me dividing every single term by 2. 2x squared divided by 2 leaves x squared. 4x divided by 2, 2x. -30 divided by 2, -15. And now I have a quadratic that's a little bit easier to factor than before, right? Because now we have that 1x squared. So let's bring down what we have. We have that 2 out front still, and we're going to factor the rest. So we know x squared will turn into x and x. We need a number that's going to multiply to 15, -15, and add to 2. And so the numbers that are going to do that are going to be -3 and +5, right? And now if we're trying to find x-intercepts, we're taking each factor and figuring out what makes them 0, right? From this factor, we know that one of our x-intercepts is 3. From this factor, we know one of our x-intercepts is -5, okay? So those are our x-intercepts of our graph, right? We can also go and find that vertex, right? We know the vertex is right in the middle. It's halfway in between. To me, these x-intercepts, I can't just necessarily look at them and figure out that magic in-between number super easily. We could think about it, or we could draw a number line, but a trick that we can always use to quickly find the middle is actually to find that average, right? We can take an average of our two x-intercepts. And remember, average, we would add up our numbers and divide by the number of numbers. In this case, we're going to divide by 2 because we're putting 2 numbers into our average function. So 3 plus -5 divided by 2 would be -2 divided by 2, which is at 1, -1, right? So this is giving us the x coordinate of our vertex at -1, right? Just like last chapter, we don't know how low to go. So if we want to figure that out, we can just take that -1 and plug it into our equation everywhere we see an x to find that y coordinate. And that y coordinate ends up being at -32. So our vertex is at -1, -32. And we also found those x-intercepts to be at 3 and -5. So we would have enough information at this point to go ahead and graph our parabola, right? So let's see what we got. I'm just going to make a quick sketch of our axes. I'm going to put my x-intercept or x-axis a little bit higher since we have to go all the way down to -32. So we know we had x-intercepts at 3 and -1, 2, 3, 4, 5. And we said that the middle point, right, the vertex, is going to be right here at -1, right? And we know that we're going down all the way to -32. And I'm just going to draw that point in just so we don't have to count. And so our parabola is going to look kind of like this. It should look pretty skinny because remember, this is a stretch. It's making our parabola grow twice as fast as a normal parabola, okay? The other thing that we want to do that's a little bit new is actually rewrite this equation in graphing form. So remember, graphing form looked something like this, right? Our A is our stretch, telling us if we're opening up and down. Our H and K are where our vertex is at. So we know that our A value from before is 2, right? The A value in standard form is the same as the A value in vertex form, okay? And if we're putting in our vertex we said was at, let's see, -1, -32. Remember, it always goes in as opposite for the x and the same for the y. So we're going to put in a +1 since it was -1 and the same thing for our y. If you were to go to Desmos and type in this equation and this equation, you would expect to see the exact same graph. That means that these equations are equivalent. They're representing the same parabola. They're just written in different forms. And remember, those different forms tell us different things about what our graph looks like. So that's going to be it for this first video. Go ahead and click on the next link for part 2.